Recently, we discovered that the brain releases huge amounts of the powerful psychedelic DMT right before you die. It's thought that this is to help you calm down and ease you through the process, but some people think it could create a vivid, permanent dream that could act as the afterlife. This is an astonishing new discovery, but it's actually far from the most interesting thing that happens when you die. So, I'm going to take you through everything that we know about the final moments that one day we all come face to face with. Much of the dying process is physical. In the final days, energy fades and muscles weaken. Things that were once easy, like drinking from a cup or shifting in bed, may no longer be possible without help. As eating and drinking slow down, bowel movements become less frequent, and the body may stop producing urine altogether. For some, that means needing a catheter. Circulation also slows, and heartbeats may feel faint or hard to detect, pulling blood away from the limbs to protect the organs. These signs can be difficult to watch for family members and loved ones, but they're usually not painful. It's just the body's way of letting go, step by step. The body's rhythm also begins to alter in more visible ways, especially in the way we breathe. One of the more recognizable patterns is called Cheyne-Stokes respiration. Stretches of deep, fast breathing followed by slower, shallower breaths, and then long pauses. It can sound uneven or strained, but it's a well-known response as the brain begins to shut down. The person isn't usually aware of this change in their breathing pattern because, at this stage, they're usually already in a deep, unresponsive state. If you're not expecting it, it can be incredibly scary. In reality, though, for caregivers, it's actually one of the clearest signs that death is very close. Another sound that often appears around the same time is one that many people find even harder to hear. It's called the death rattle, a wet, gurgling, or sometimes snoring sound that happens when a person can no longer clear secretions from the back of their throat. At this point, they've usually lost the ability to swallow or cough, so saliva and mucus begin to collect and amplify with each breath. The sound itself can vary. It might be soft and crackling, or loud and harsh. And while it can sound like choking or gasping, it's important to know that the person isn't in pain. In fact, they don't know that it's happening at all. It's a common part of the dying process, and nurses can help manage the sound with repositioning, gentle suction, or medication. But the rattle itself is natural. More than anything, understanding what it is can ease some of the fear and allow family members to stay close, knowing that it's okay to be there, even if the sounds aren't easy to hear. But not everything that happens near the end is physical. Some of the most powerful moments are emotional. There's something known as terminal lucidity, though hospice workers often call it the rally, a sudden, unexpected burst of clarity in someone who's been slipping away. A person who hasn't spoken in days might suddenly ask for their favorite meal, share a memory, or say goodbye like nothing was ever wrong. It's not a sudden recovery, though it may look like one. More often than not, it's one of the clearest signs that death is close, usually within 24 to 48 hours. Doctors don't fully understand it, but many think it's triggered by a final surge of brain activity or a hormonal shift. Others see something more spiritual in it. Either way, for those in the room, it's a bit like a final gift. At the same time, something else can begin to appear. In the end, a lot of people start to experience vivid hallucinations. These aren't dreams or confusion from medication. Patients often describe seeing long-deceased relatives, familiar places, or comforting figures. Some speak to people no one else can see. Others describe scenes that feel more real than their surroundings. It's more common than most people realize, especially in hospice or end-of-life care, and it's not necessarily a sign of distress. These visions are often peaceful, and many people describe a sense of calm or even joy during them. They may be triggered by a mix of things: lower oxygen levels, dying brain cells, emotional stress, or even a final neurological surge. Some see it as a purely medical phenomenon. Others believe it's something more. If you're lucky enough to be there, and someone you love begins to hallucinate near the end, the best thing you can do is stay present, stay gentle, and remind them that they're safe. For them, that moment may feel like a bridge, not just to memory, but to somewhere beyond. The next change is chemical and just as important. As the body begins to shut down, it releases a powerful wave of neurochemicals and hormones designed to soften the experience. Endorphins, the body's natural opioids, are released in large quantities during extreme stress, including at the point of death. They help dull pain and create feelings of calm or even euphoria. Serotonin, which affects mood and perception, also spikes. It's the same chemical involved in psychedelic experiences, which may help explain the vivid imagery and spiritual sensations described by people who've had near-death experiences. Some researchers believe the brain might also release DMT, a naturally occurring psychedelic compound linked to feelings of transcendence and altered perception. Add in adrenaline and noradrenaline, and together the chemical changes do what they can to protect us one last time, mentally, emotionally, and physically. Once the lungs grow quiet and the sounds fade, what follows is a final invisible line, the one drawn by the brain. In most countries, including the US, death is legally defined as the irreversible loss of all brain function. That means a person can still have a heartbeat, still be hooked up to machines, and still be considered dead. It specifically comes down to the brainstem, the part that controls basic survival functions like breathing, heartbeat regulation, and consciousness. Once the brainstem shuts down, the rest of the body quickly follows. Even in cases like drowning or heart attacks where the heart stops first, death isn't official until the brainstem loses all activity. Now, the moment brain activity stops, a cascade begins. Inside the cells, things start to unravel quickly. Without oxygen, neurons don't just disappear, they go into overdrive. Within minutes, they release large amounts of glutamate, a neurotransmitter that normally helps send signals between cells, but in this state, it becomes toxic. The excess glutamate floods neighboring neurons with calcium, which activates enzymes that begin breaking the cells apart from the inside. This process, called excitotoxicity, causes neurons to self-destruct, tearing through their own proteins, membranes, and even DNA. The damage also spreads to nearby neurons, setting off a chain reaction that can't be reversed. That's why every minute matters when oxygen is cut off in drowning cases, for instance. Once this begins, the window to stop it closes fast. Apart from neurons destructing, we've also come to learn that the dying brain can enter a temporary spike in organized brain activity. In animal studies, researchers observed that just after the heart stops, the brain suddenly lights up, and it seems to be coordinated electrical activity. In rats, this surge affected the regions of the brain tied to vision and perception, even though oxygen was no longer flowing through their bodies. One theory is that this could explain why so many people report seeing a bright light or tunnel in their last moments. The visual cortex may be firing in overdrive as the brain responds to its last signals. While we can't confirm it in humans just yet, the timing and pattern strongly suggest that the light at the end might be more than just a metaphor. Of course, if the brain is lighting up like that, that final surge may also bring on a strange heightened clarity. People who've come close to death often describe an overwhelming sharpness, lights that seem impossibly bright, sounds and sensations that feel more vivid than anything in waking life. Some interpret it as a spiritual experience, while others describe it as something far more sensory and surreal. From a scientific standpoint, many of these reports are thought to come from the brain's final moments of activity. If consciousness exists on a spectrum, then the last instant before everything shuts down might actually be the most intense version of it we ever experience. So the last thing we feel might not be fading, it might be clarity, which is unexpected to say the least. It's also interesting to note that this surge in awareness might explain something else: near-death experiences. Many people who've been revived after coming close to death describe incredibly vivid moments, lights, a sense of floating, and scenes that feel more real than reality. Some recall sounds, smells, or sensations they've never experienced before. But one of the most common features is time distortion. Not just a shutdown, but a complete breakdown in how time is experienced. Studies, including work by Bruce Grayson, have found that up to 70% of near-death survivors report some form of time distortion. Some say entire lifetimes of memory flash by in seconds. Others describe time disappearing completely, like it no longer applies. A near-death experience might be something that's 100% spiritual, but from a brain science perspective, researchers think it has more to do with how the brain responds under extreme stress. I don't know. Maybe time changes when you die, so much so that it never ends. And then there's the fact that death might be more predictable than we thought, at least when it happens naturally. Researchers have found that, much like sleep, appetite, and mood, the timing of death may be tied to our circadian rhythm, the internal clock that runs in the background of everything we do. In one study, people who died in the morning had noticeably different biological clocks and even different brain compositions compared to those who died at night. And it got stranger. Researchers in California looked at the brains of people who had died suddenly, through trauma or accidents. They thought that these cases wouldn't follow the same rules, but they did. Even though a car crash or sudden injury doesn't give the brain time to prepare, the same pattern showed up, which suggests that certain changes in the brain don't start at death, they're already in motion and continue unfolding the moment our lives end. So if the brain is already changing in the hours leading up to death, that raises another question. How do we actually measure when it's over? Well, the answer is not as straightforward as we'd like. An EEG, or electroencephalogram, measures electrical signals in the brain, specifically the surface level activity in the cerebral cortex. If that reading goes flat, it usually means the thinking part of the brain has gone silent. The issue with that is that EEGs can't detect activity in deeper brain regions like the brainstem or midbrain. In one animal study, researchers actually recorded the flat EEG shortly after cardiac arrest, but still found brief electrical signals firing deep in the brain for up to 30 minutes later. That's one of the main reasons why doctors don't rely on EEGs alone when diagnosing brain death. They also check for reflexes controlled by the brainstem, like pupil response, breathing effort, and the gag reflex. On a different note, did you know that here in the US, you can be legally dead in one state, yet still considered alive in another? Back in number 19, I talked about how most countries, including the US, define death as the irreversible loss of all brain function. Once the brainstem goes, that's it. But not everywhere agrees. In New York and New Jersey, for example, families can challenge that definition based on religious beliefs. So if someone is declared brain dead in California, they might still be treated as alive in a hospital across the country. Either way, depending on which state you're in, that difference doesn't just change a definition, it can decide everything, from how you're being treated to whether your organs are eligible for donation, a process that runs on a tight clock. Once brain death is confirmed and consent for donation is in place, surgeons have to move fast. The heart is usually removed first and has to be out of the body and on ice within minutes, ideally transplanted within 4 to 6 hours. Lungs follow a similar timeline. The liver comes next, with a window of about 8 to 12 hours. Kidneys can wait a little longer, sometimes up to 36 hours if properly cooled. Corneas are usually removed last and can remain usable for several days. Every minute matters, which is why transplant teams are often already prepped before the machines are switched off. Alright, once the brain fully powers down, the cooling starts almost immediately. This stage is known as Rigor Mortis, the natural drop in body temperature after death. As soon as the heart stops, the body begins to lose heat, typically at a rate of about 1.5 degrees Fahrenheit per hour. Eventually, it equalizes with the surrounding environment, but how fast that happens depends on a bunch of factors: air temperature, body fat, clothing, and even where the person died. Forensic scientists actually use this cooling to estimate the time of death. There's even a formula for it, the Gleister equation, which calculates the number of hours since death based on how far the body temperature has dropped from the normal 98.4 degrees Fahrenheit. It's not foolproof, especially if the body was found in extreme conditions, but it's still one of the first clues investigators use to figure out when someone died. And naturally, while the temperature drops, blood isn't circulating anymore, which means gravity steps in. Within 20 to 30 minutes after death, blood starts to pool in the lowest parts of the body following the pull of gravity. This is called postmortem hypostasis, or livor mortis. At first, the reddish-purple patches that appear are still movable. If you press on the skin, it'll briefly turn pale. But after about 6 to 12 hours, that blood settles for good and stains the tissues, kind of like a bruise. Just like with rigor mortis can be used to estimate the time of death and even to determine whether a body was moved around after the fact. I think we are all familiar with what happens next, even if we don't quite know why it happens. Rigor mortis, that stiffening of the body you see after death, is actually caused by a chemical shift in the muscles. When someone dies, the body stops producing ATP, the energy molecules that normally helps muscles contract and relax. Without it, the muscles lock into place and can't release. It usually starts a couple of hours after death, beginning with the eyelids and jaw, before moving through the rest of the body. After about 12 hours, the stiffness is at its peak, and then, over the next day or two, it slowly fades as decomposition takes over. Heat speeds it up, cold slows it down, and if someone exerted themselves right before dying, rigor might show up even faster. On rare occasions, something even more dramatic can happen. It's known as a cadaveric spasm and refers to a sudden, intense stiffening that happens right at the moment of death. Unlike standard rigor mortis, which sets in gradually and can be worked out of the muscles, cadaveric spasms lock the body in place immediately, often in the exact position someone died. It's most often reported in violent or highly emotional deaths, like soldiers with weapons still in hand. There's little scientific consensus about how or why it happens, and many forensic experts think what we're seeing might be something else entirely, like gravity, nerve damage, or just the mechanics of muscle contraction under stress. Still, when it does appear, it's hard to ignore. I should also mention the changes to the eyes, and more specifically, a whole chain of reactions inside the eye that can actually help pinpoint when someone died. The pupils dilate and stop reacting to light almost immediately after death. Within a couple of hours, the corneas begin to cloud due to dehydration and lack of oxygen. If the eyelids aren't closed, the surface of the eye starts to dry out and darken, forming what's known as tache noire, a reddish-brown stripe that stretches horizontally across the exposed area. Intraocular pressure also drops steadily over time. Even the eyeball's chemistry changes, with changes in potassium levels and corneal thickness forming patterns that have been used by researchers to estimate the time of death down to the hour. Once the muscles have had their final say, the real breakdown begins. Your body is full of bacteria, most of them helpful during life, but the moment you die, the balance shifts. Without an immune system to keep them in check, those microbes start digesting you from the inside out, beginning at the intestines. Not long after, bacteria from your skin and environment join in, working their way from the outside in. In some cases, however, something strange can happen. If the body is in a cool, damp place with limited insect activity, fat deposits can undergo a chemical transformation. The result is adipocere, also called grave wax, a chalky white substance that forms in fatty areas like the cheeks, abdomen, and thighs. It resists decay and can preserve a corpse for years, sometimes even over a century. Which brings us to the fact that some of your cells will continue doing their job long after you've died. In 2021, researchers at the University of Illinois Chicago found that glial cells, the ones responsible for cleanup and repair in the brain, were still growing, spouting long appendages, and activating genes linked to inflammation hours after death. In fact, they peaked at around 12 hours post-mortem. So while some things shut off, others are only getting started. The same goes for some genes. In studies on mice and zebrafish, researchers found that over 500 genes actually switched on after death. Not immediately, but hours or even days later. Many were genes associated with development, like the kind that are usually only active in embryos. And therein lies the mystery. No one's sure why this happens. It could be a final response to stress, or maybe an unregulated surge as the usual cellular checks fall apart. Either way, it's another sign that death isn't a clean break. Now, it might surprise you to learn that there's still an ongoing debate about when we're actually dead. Some say it's when the heart stops. Others insist it's when the brain goes quiet. And then there are those who believe death doesn't really happen until the body has gone cold. Even in hospitals, the moment of death isn't always simple. Brain death is considered the legal standard in many places, but biologically, things keep going. Cells don't die all at once. Some keep living and dying for hours. So, what does that make us? Are we our thoughts? Our breath? Our biology? Scientists can measure when neurons stop firing or when organs fail, but they still can't define the exact second that the self disappears. And to be honest, depending on who you ask, that moment might not be medical at all. Finally, it's clear that even after we've technically died, there's still enough activity in some genes and cells to carry on with their work. And as science and technology keep evolving, our understanding of when death actually happens keeps shifting. There was a time where no heartbeat meant someone was definitely gone. Now we know it's not that simple. Death isn't a hard stop. It's a process that might be a lot more flexible than we thought. And that flexibility is exactly what's driving new conservations, new research, and new questions about what it means to be alive. Biotech companies around the world are paying close attention. Although we are very far off from doing it, some are actively exploring ways to undo brain death, or at least delay it in the hope that one day we might actually reverse it. I know, it sounds far-fetched, but nature already has some tricks up its sleeve. Some animals can regrow limbs. Others can turn a severed body part into a whole new creature. The space between life and death isn't a hard line. It's a blur we're only beginning to understand. And maybe that's the point. Maybe part of being human is learning to live with the mystery of how it all ends. And that's a wrap. Did I cover it all? What do you think should have made the list? Now before you go, let's do a quick trivia challenge. How long after death can kidneys remain viable to transplant if properly cooled? Is it A, 12 hours, B, 24, C, 36, or D, 48 hours? Drop your answers in the comments below. And you know what? If you're into strange facts with a slightly sketchy edge, then you're going to want to check out our next video, 25 Facts That Feel Illegal to Know. It's got websites with uranium for sale, a few legal loopholes, and even a way to speed without ever getting a ticket. And as always, thank you guys so much for watching. Hit that subscribe button, ring that bell. I promise we say it a lot, but it really does help. And I'll catch you guys again next time. So yeah, I'm going to dedicate this one to my grandmother who recently passed away. So rest in peace, Grandma Charlene. I miss you.